This video is for section 4.6, day 1. The next 2 days we're going to be talking about related rates. And related rates is one of the FRQs on the AP exam. So this section is going to be very heavy. That's why we're spending 2 days on it. You'll also see problems similar on your test. Over chapter 4 you could see an AP level type problem on that test, so it's a good thing to prepare for. Related rates equations are equations that involve two or more variables that are differentiable functions of time. This is similar to implicit differentiation because we're going to take things and differentiate them implicitly all the way across. So multiple variables, all with respect to time. So first example, assume that the radius r of a sphere is a differentiable function of t, and let v be the volume of a sphere. Find an equation that relates dv of t and dr of t, dt. So really all we're trying to do is find v prom. But we need to find the derivative of v with respect to time and the derivative of r with respect to time. So the derivative of v is dv dt. If we go through, the derivative of r cubed is going to be 3 times 4/3 pi r squared, and we did the derivative of r with respect to time, so dr dt. Well, here my 3's are going to cancel, and I'm going to end up with dv dt equals 4 pi r squared dr dt. So you can see for every variable that we're taking the derivative of, we're doing it with respect to t. So we include that dt part with each of our variables. Okay. So if we move on to another one, a hot air balloon rising straight up from a level field is tracked by a rangefinder 500 feet from the liftoff point. At the moment the rangefinder's elevation angle is pi over 4, the angle is increasing at a rate of 0.14 radians per minute. How fast is the balloon rising at that moment? So, what we have to think about here is what's happening. So in a lot of these cases, you're going to have to draw a picture. So if we start drawing our picture, we know an air balloon is rising up, straight up. So here's my balloon going straight up. Alright, and this has height h. Alright, it's being tracked by a rangefinder 500 feet from the liftoff point. So over here, 500 feet, is my little rangefinder. It's tracking it. The moment the rangefinder's elevation angle is pi over 4. So when I look up, notice here I have a right angle. This angle is pi over 4. The angle is increasing at a rate of 0.14 radians per minute. How fast is the balloon rising at that moment? Well, we want to know how fast the balloon is rising. So we're actually looking for dh dt, because that's our change in rate of the height. Alright? We know that theta is our current pi over 4. We know that we have a right triangle, so we could say that this is my opposite side, and this is my adjacent side. So we have a formula that says the tangent of theta equals opposite over adjacent, h over 500. We can solve for h by multiplying both sides by 500, so h equals 500 tan theta. Well, I want to find dh dt. So, to get dh dt, I do the derivative. Derivative of h is dh dt. The derivative of 500 tan theta is 500. The derivative of tangent is secant squared. Whoops, I didn't leave myself very much room here. So 500 secant squared theta d theta dt. Alright, so now we have to go back to the original problem and figure out where we're at. Right, a rate The angle is increasing at a rate of 0.014. So d theta dt is 0.014. So that's what we are going to plug in. Now we also know that our theta was pi over 4. So I have 500 times secant squared pi over 4 times 0.14. And that's going to give me my dH dt. Well, if I type all of that into my calculator, I get dH dt equals 140, and we are talking about feet, and we are talking about minutes, so feet per minute. And you have to make sure you label these. Your labels will count for points. They will also count for points on an FRQ on the AP exam, so make sure you're very accurate with your labels. So, if we take a big general look at this, first thing we did was we drew a picture to get an idea of what was happening. Once we drew that picture, we used our picture to come up with an equation. Once we had our equation, we took our equation and we found the derivative. We did implicit differentiation so we could find the derivative for both variables in place. Then, once we had our derivative, we went back to the original question and plugged in the values we knew. We knew theta, the original angle, was pi over 4, and we knew the angle changed, so d theta was 0.14. Plug those into our calculator, get our answer. This general rule will come up over and over again. Let's look at another example. Example number 6 from page 251. If A and B are the lengths of two sides of a triangle, and theta is the measure of the included angle, the area A of the triangle is A equals 1/2 AB sine theta. How is the derivative of capital A related to the derivative of little a, little b, and little theta? Well, now we're doing some big time implicit differentiation. To do this problem, we essentially have three product rules going on here, because we have A, we have B, and we have the sine of theta. So we're going to set up U equals 1/2 A, V equals B, and we'll say W equals the sine of theta. Then U prime is 1/2, V prime is 1, and W prime, derivative sign, is cosine. So we know everybody essentially needs to be multiplied by everybody else. So this is going to become dA dt equals du times v times w plus u times dv times w plus uv times dw. Okay, now remember, this 1/2 over here is dA dt, this is dB dt, and this is d theta dt. So when we go to plug these guys back in, we're going to end up with, let's give ourselves some more room here, dA dt equals du, which is 1/2 d little a dt, times v times w, b sine theta, plus u, which is 1/2 a, times dv, which is dB dt, times w, sine theta, plus uv, so 1/2 ab cosine theta d theta dt. So there is my derivative of a dA dt related to d little a, d little b, and d theta. And notice I have a dA dt, d b dt, d theta dt in my answer. Looks like a long, complicated problem. Actually, not too terrible. Alright. Now, your homework is page 251, 1 through 11 odds. I have also included on eChalk the evens for all of 4.6 that we may get to. So that'll also be posted to eChalk for you to go back and look at if you have any questions.